And welcome everybody to the Space Weather Show. It's just the world's most comprehensive space weather show and most detailed solar imagery you'll find in the known universe. I'm your host, Dan, a.k.a. Smash-O-Mash, coming at you from the Smash News Network, least busted name in news. And it's always exciting to see a nearly X-class event popping off. It was an M9.4, something like that, class solar flare. You'll see right at the end of that video there. And it did indeed produce an Earth-directed coronal mass ejection. We'll cover it and lots more. Let's take a brief look at the past 3 days from the SDO's 171 angstroms wavelength. And we've got a dip in sunspot number, but again, like I said, we do have a coronal mass ejection on the way. It is likely to arrive sometime around midday on November 13th. Again, we'll cover more on that in a bit. In the meantime, let's talk about some stats about space weather. And again, thanks for tuning into the Smash News Network, least busted name in news. The radio flux is kind of down here, down to 221 solar flux units. 221 is the radio flux at the moment. And if you're wondering what that is, the sun emits radio frequency electromagnetic radiation from its upper chromosphere and lower corona. And that is the most proportional data set that we have to sunspot number. In other words, a high sunspot number means a high radio flux, and vice versa. So anyway, that's the scenario for the radio flux. There's our solar cycle progression. I just figured I'd bring that up to show you how average solar cycle 25 is. If you were worried about the sun shutting down and spooked of that, well, you can stop worrying because, again, as you can see, solar cycle 25 is panning out to be an average sunspot cycle. So you won't see the forecasts from NOAA or ESA yet, or from NASA, as the latest coronal mass ejection just happened. It just showed up on the coronagraph, and it's quite earthly directed. In fact, it's quite directly earthly directed. It's only off a little bit to the south. So that should create some significant geomagnetic storm conditions. And we'll talk about where to view the aurora. Again, you won't see the forecasts yet on ESA's website or on NOAA's website. So that won't be modeled yet. We're coming at you pretty rapidly. So let's take a brief look at some more stats here. We did see a brief geomagnetic storm period, and we've got some great shares on Twitter. Make sure you follow us there if you haven't. More on that in a little bit. Solar wind is pretty nominal here. It looked like we were going to get a little bit more geomagnetic storm conditions, but not so much. We did see a little increase there in the solar wind density up to about 20 protons per cubic centimeter as measured by both ACE and Discover, I thought. Let's make sure. There's Discover. We already showed you ACE. There's Discover, and yeah, Discover saw even higher levels there, about 25 protons per cubic centimeter at Discover, about 20 at ACE at that same time. So there's ACE, and there's Discover. So a little bit of solar wind activity coming in here. Looks like it could be a weak coronal hole high-speed stream there. Very weak. And yeah, it's not a super exciting coronal hole high-speed stream. So as far as the heliosphere magnetism goes, Earth remains in a North Pole-oriented sector here where we can expect to stay for quite a while. North Pole magnetic sector. So here's our solar B field depicted in blue, polar fields in red for south and green for north. And you can see a lot of potential field surface source lines here kind of oriented right at you, the viewer. Why? Because of coronal holes. So there you can see a bunch of North Pole-oriented coronal holes, exactly as we've been forecasting on the channel. So expect to see lots and lots of North Pole-oriented coronal holes here, as the South Polar field migration is sort of ahead of the North Polar field migration. You can see lots of green there around the solar equatorial region. That's what happens. The solar polar fields migrate from pole to pole throughout the cycle. And yeah, the North solar polar field migration is behind the South solar polar field migration. With time, that is going to get closer and closer to the south heliographic pole as we ramp down solar cycle 25. So here's a 48-hour video of coronal holes there. The exquisite 211 angstroms wavelength is great for showing those. And some of those are going to become a little more well-defined here as they get themselves oriented more toward Earth, since those are indeed covered up by the bumpiness of the solar corona. So yeah, coronal holes to continue here, and indeed some space weather from coronal holes should be expected. Sunspot number here is right around 170 sunspots. And let's take a look at sunspots from the perspective of SDO's fantastic HMI instrument. There you go. There are sunspots. Again, sunspot number around 170. And we do have some significant magnetic complexity in that group that just rose there on the eastern limb. That's another 3-day video. And let's show the magnetogram. Again, that group farthest to your east, which would be your screen left, that remains the most likely place to see continued large solar flare. So we do see some deltas in there. Beta gamma delta class sunspots are the most flare producing type of sunspots, and we do have a little bit of that activity going on. So yeah, don't be surprised to see more large M or even X class events. Always exciting to see a CME headed in Earth's direction. Speaking of flares, here are the past 3 days of flares. You can see that one event there was indeed very close to an X-class event. An M9.5 approximately there. An M9.5 rounding to the nearest tenth of a magnitude. And here are flares. That's a 3-day video of the 131 angstroms wavelength. So that is the hottest wavelength. That's about 18 million degrees Fahrenheit. And you'll see right at the end of that video, wait for it, and there it is. No, wait, there it is. A nearly X-class solar flare. Now we're going to show some more detailed images here. Allow me to get out of the way. Here's 94 angstroms. Not quite as hot as 131 angstroms, but another great wavelength at showing flare activity. And we did see some limb darkening, an indication that a coronal mass ejection was generated. So here we've zoomed in and we've added the 304 angstrom 60-minute running difference. We also do have some incredible solar plasma filaments, which we will show in great detail here a little bit later in the video. And here's 131 plus 304 angstrom 60-minute running difference. That way you can see the filaments and the flare activity all happening together. Good times, good times. And if you're enjoying the content, make sure you leave us a comment, and don't forget to visit the links in the description below the video. Moving right along, here's our solar system forecast. This is where things are today. We'll move this forward 1 week for your solar system forecasting pleasure. That's where things will be on the 17th of November. We will be just after a new moon. So we're like 5 or 6 days out from a full moon here. And this is what's going on over our head right now. There we are. You've got Mars up there right now. And if you're wondering where we're located in Lehigh Valley, Pennsylvania. Cycling Mecca, Lehigh Valley, Pennsylvania. And let's move along. I like the astronomy photo of the day. It's the Grand Canyon of Mars, folks. That's like 8,000 kilometers long. It's or 3,000 kilometers long. It's a little bit bigger than the Earth's Grand Canyon, indeed. And it's like 8 kilometers deep. It is quite a huge gash on the side of Mars. Of course, a very famous feature in the solar system, the Valles Marineris, the Grand Canyon of Mars. Again, we just did see a CME pop off, and we're going to show some custom composite videos. Right at the end of that, you'll see some ejecta mainly coming out of the south there, but it is earthly directed. So we'll briefly show the LASCO C2 and C3 side by side, and then we'll show them together in spectacular format. But first, again, don't forget to press the like button, press subscribe if you're new to the channel. Congratulations on realizing the channel exists. We remain surprised that you have. You might find quite a bit of content about space weather on the channel, so make sure you don't miss future videos. So here's a 3-day video of coronal mass ejections. We've got the 304 angstroms there, the 193 angstrom 60-minute running difference, and the LASCO C2. You'll see right at the end a little bit of ejecta there coming out of the south. That is an earthly directed coronal mass ejection associated with that M9.5 class solar flare. Here we'll zoom out to show the LASCO C3 as well. Some great footage there, courtesy of helioviewer.org. We will get into some brief weather coverage here, some Earth weather. And don't get them confused, folks. Earth weather and space weather are separate things, right? Earth weather ends at the top of the mesosphere. Space weather ends at the bottom of the ionosphere. That literally is the boundary between space weather and Earth weather. Space weather occurs where most of the material is ionized. Earth weather occurs where most of the material consists of neutral particles. Next, we'll talk filaments, since we've got some of the most massive filaments ever covered on the channel after over 6 years of space weather coverage. That filament there in the southern hemisphere, you can see it as a huge dark colored absorption feature there. That might be the largest filament that we've ever covered. It is hundreds of Earths in diameter, the total length of that filament. It's still attached. And that one might make its way all the way to the western limb there. But if that one does launch, especially right around now, that could be a very much major geomagnetic storm just waiting to happen. So here we'll show it. Let's show it again here. There's the view in 304 plus 193 angstroms, 60-minute running difference. And what a view. It's another 3-day video there. And let's take a look a little bit closer here. Check out that plasma filament. That is one for the record books, folks. It is not just large, but very dense. And don't forget, that's a 3-dimensional feature. So it's thousands and thousands of kilometers tall. It's probably something like about 18,000 kilometers above the chromosphere. And hundreds of thousands of kilometers in length. A properly massive plasma filament. Again, don't forget to follow us on X when we do see geomagnetic storm conditions. We have a great network by which we share auroral imagery. So check us out over there. And let's do a little bit more space weather stuff here. We do have some massive plasma filaments there hanging off the edge, known as prominences, which are visible in Cerro Tololo's grayscale imagery. In hydrogen alpha. Here are the past couple of hours, and you can see that Earth-directed CME there popping off following that M9.5 class solar flare. There it is. And a lot of that material is headed toward Earth. So excited about that. And next we'll talk about sunspots. There's our latest high-res image. There's our latest high-res magnetogram. And let's show that group right there where the action has been coming from. And we do have some minor deltas in there, but it's primarily a beta gamma class sunspot group. Again, that is the most likely place to see large solar flares in the coming days. Now, let's bridge across from space weather to Earth weather, and here's a great place to do it, the Neutral Atmosphere Nowcast. So it's showing you the neutral particle density there up to 400 kilometers of altitude. That is showing you both Earth weather and space weather. The oxygen to nitrogen ratio there. And yeah. So moving into Earth weather here briefly. We're showing the North Atlantic now. And there you've got, indeed, massive low pressure systems there in both the North Pacific, south of Alaska, as well as the North Atlantic. That one south of Alaska is quite violent. That is a very strong low, like a late fall, like a fall hurricane, essentially. Here's our satellite imagery as the sun rises over the west coast. Windy.com, we're showing snow depth right now, and Colorado is quite blanketed. So all the hot air in the world present in Colorado is unable to melt that much snow. So here's our weather.gov forecast map. You can see some tropical storm advisories there in the Gulf. And let's show some forecasts here. Here is our 72-hour positive snow depth change forecast from Tropical Tidbits. That's the GFS model. Again, 72-hour GFS snow depth change forecast in inches. A little bit more snowfall in there. The heaviest will be in Washington and Oregon. We'll also show the total accumulated precipitation forecast there. Washington expecting some heavy rains, as well as southern Louisiana. Finally, some rain coming to the northeast, where there have been red flag warnings out the yin-yang, and parts of the Blue Mountain in Pennsylvania have been burning. Here's our GFS 72-hour, that is pressure and precipitation forecast. Figured we would chime in with a little bit of weather stuff. There's our lightning map, and lightning is pretty calm here at the moment. Let's just skip that. Here's our radar map, as there is a system moving to the northeast. And here's our satellite imagery, and a brief look at the water vapor map. So that's the scenario, folks. And we'll close out with some great imagery here. That is today, November 10th, in the SDO 94 angstroms wavelength. So enjoy that. Hopefully you enjoyed today's space weather video. Thanks for tuning in. And until next time, may that solar wind be at your back.